Hello, good morning, and welcome back to Refactoring Bitcoin. In the last video, I have shown how to add tests to a CMake project, how to enable testing, and then run the tests with CTest. And I also mentioned that the approach of having one test executable per test does not really scale. And there are two approaches of combining multiple tests to a single executable in CMake. One is provided by CMake, and the other approach is using a testing framework. So the built-in approach that is provided with CMake is something that I will show in a separate video. In this video, I will concentrate and I will present the approach of using a testing framework. The most widely used testing framework in C++ is probably the Google testing framework called GTest. So this is what I want to show in this example here. So at the top of the CMake.list.txt file, I first find the dependency called find package, and the name of the package is GTest. And this will be required. So I set this as required. I will comment out this code here because this is something that as I said, there is a built-in way to combine multiple test executables. And in a separate video, I will show how to combine those two executables or those two tests into a single executable. For the Google test example, I will create a new file. I will call this gtest.cpp. Okay. And inside this file, I have to include the header for the testing framework. And this is called gtest.gtest.h. Okay. And now you imagine that you also include test header, the headers of your library under test. And now you add the tests, which in the Google testing framework is done with the test macro. This macro takes two arguments because the Google testing framework organizes the tests in a two-level hierarchy. So the top level will be called, I just call this test one, and the second level, I just call it sub one. Okay. And in this test, I will use an assertion that always succeeds because I want to present how to make a test that succeeds. Okay, so I will use assert true, and I pass true. Okay, this should always succeed. And I also want to present a second test that always fails. So this one is called test2, sub2, and here I pass false. So this is something that should always fail. Okay, in a Google testing framework, you can link multiple source files, and each source file can contain multiple tests. So in this example, I put both tests into a single source file. In the CMake.list.txt file, I now add the executable. This is called GTest, and the source file will be gtest.cpp. And of course, I also have to link my library under test, copy the line from here, make sure to change the test target to GTest. And in addition to my library under test, I also have to link the test executable, the testing framework, of course. So this is called GTest GTest main. And what's nice here is that this library actually provides the main function for my test driver. You see in the source file here, I don't write a main function myself. I just add these individual tests here, and the main function is now provided by the testing framework. Okay, now let's see how to build this. We go into the build directory and run CMake. And you see in the output here, it says it found GTest. and configuring was successful. Now I run the build. It's built successfully. And now I can run this text executable. So this is tests/GTest. And you see in the output that we have one test that succeeded and one test that failed because the value that I provide, false, is not the one that is expected. Expected would be true. So this is exactly what we actually expect, right? So we wanted to show a failing test. So this is nice. Okay, this is now how we can add multiple tests into a single executable and then run them all at once, and we get the output: which tests passed and which tests failed. Okay. There is also a problem with this approach, of course. And the problem is the following. Imagine that, I mean, for our Bitcoin kernel library, for example, we want to provide language bindings for multiple languages. So we have tests that are written in C++, but we will also have tests that test the Python language bindings. And obviously, those tests should be written in Python. So we should also have we cannot compile the Python tests into our C++ executable. So we cannot have one executable that runs all the tests. And then now you imagine we will just have one executable per language, right? We have let's say we use the Google testing framework for C++ tests. We use let's say PyTest for Python. That means we run the C++ tests separately from the Python tests. But now the problem is, yeah, we have two approaches. If we either let's say run the CMake tests and the C++ tests in such a way that it uses all the resources, so we parallelize on all cores. And if you run the Python tests at the same time, those two testing frameworks will compete for resources. Okay, so this is not a good idea. If we instead run them sequentially and use all resources, that means if we have a single long-running test, let's say we first run all the C++ tests and then run all the Python tests. So we have several small C++ tests that will finish rather quickly. And we have, let's say, a single long-running test. So that means one single core will be busy until that test finishes, and only after that we run the Python tests. So this scheduling is not great. So we see here that combining multiple tests into a single executable is useful. This is what we want, but we do not want to use the testing framework to actually schedule the testing. We still want to schedule the tests with CTest, and that way we can run Python tests and C++ tests in parallel, and because CTests will take care of all the scheduling. So in the next video, I will show how we can actually add the testing, the individual tests separately as separate processes to CTest, and then use CTest to parallelize them. Thanks for watching, and goodbye.